Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the SugarCube format for Twine. A couple of videos ago, I showed you a map generator that I had coded, which generated fairly realistic looking areas of land and sea and then displayed them. But it had it had a pretty severe problem once you noticed it. And that was that it tended to create areas of the same colour, representing height above sea level or the depth of the sea, which ran sort of at a 45-degree angle from the bottom left to the top right. So you would have areas of the same depth of sea or mountain ranges or coasts, whatever it may be, and they all tended to run sort of like that. Now, it wasn't exactly like that. They weren't sort of literal stripes, but it was noticeable once you saw that it was doing that. It was noticeable, and it sort of looked a bit unrealistic. Well, I've made a new version of this generator, and as you can see, this map that I've generated doesn't really have a set slope, certainly not one in that way. And if I restart it, we might find that this one, if there is a slope, it seems to be going sort of almost the opposite direction, from the top left to the bottom right. And if we keep going, we'll get, well, that one sort of, maybe you'd say that was going sort of gently top left to bottom right, but it's not like the previous one, and so on. That one is sort of a very severe angle. That one sort of, not as obvious, and so on. That one looks more like the ones that we were getting before, and of course some of the ones with this version will, but you'll find that there's a much greater variety. So, what have I done? Well, basically what I've done is I've changed I've changed the order in which we determine the squares and which squares influence which squares. And that changes the sort of average curve of the land, I suppose. And I'll tell you more about that as we look at the code. So we'll just get out of that. Once again, it's a very simple program. Initialize, we set up the variables. Generate map, we generate the map. Print map, we print the map. And there's not a lot of changes that I had to make, actually. So much so that print map, this passage is identical to how it was before. So we won't be looking at that. It works in exactly the same way as it did in the version that I showed you a couple of videos ago. And we only have one change in initialize. And that change is adding a variable, which is what allows us to have these different sort of orientations of land. That variable I've called upchance, $UPCHANCE, and it is initially set once at the start of the program to a random number between 0 to 100. And what does that do? Well, it says it here. It is the percentage chance of generating a given column from the bottom up as opposed to from the top down. Okay, so what does that mean? Well, the way that we were generating the map in the first version is we would generate the left-hand column. So every square that had an x value of 1, we generated them. And then we generated the bottom row, every square that had a y version of 1, except for the bottom left-hand corner, which we generated separately. And then we'd go through each column, starting at 2, 2, then we'd do 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, then 4, 1, 4, 2, then 5, 1, 5, 2, and so on, until we'd filled in the map. And the way that it worked is that each square was influenced by the height of the square to its west and to its south, and each square influenced the square to its north and to its east. But that has a consequence. It means that if, let's say we have square 2, 2, well, that will influence squares 2, 3 to its north and 3, 2 to its east. Both of those squares will influence 3, 3. So if you have a square, it's influencing two squares, and then those two squares influence another square, that second square is likely to be the same as the first square because it's being influenced sort of twice by two squares which were in turn influenced by the first square. And because there's randomness, because it's influence, it's not determining it, it's just influencing it, and random chance still plays a part. It won't be sort of straight up stripes, but you will get a tendency for square 2, 2 to be the same as square 3, 3, which will tend to be the same as square 4, 4, which will tend to be the same as square 5, 5, etc. In fact, each square will tend to be similar to the square immediately northeast of it. So square 2, 5 will be the same as, will be similar to square 3, 6, and so on. And so you'll tend to get these 45-degree stripes. Now, that's because we're going from the bottom up. Well, we could, of course, go from the top down. We could start with, let's say, 2, 100, and then do 299, 298, 297, 296, etc. But then we'd have a sort of equal and opposite problem. Squares would tend to influence the squares to their southeast, and so we'd get stripes that were still at roughly 45-degree angle, but going in the sort of opposite, or going at a 90-degree angle to the ones we were actually getting. So that's not super helpful either. What we want is a mixture. We want to sometimes mostly go up, generating those 45-degree stripes that we were getting originally. Sometimes we want to mostly go down, generating different 45-degree stripes. And sometimes we want to go sort of sometimes up and sometimes down. And that will tend to generate sort of straight east to west lines. In other words, we want the lines to be varied. And that's what we do with upchance. We set it to a value at the start, and then in each column, we're going to use random chance and compare it to this upchance variable so that we'll tend to get, sometimes we'll get up, sometimes we'll get down, but we'll tend to get sort of consistent slopes across a given map, but the angles will be different from map to map. So let's look at how that works. Look in Generate Map. We set the lower left-hand corner. That's exactly the same as it was before. We set the left-hand column. That's exactly the same as it was before. We don't set the bottom row. We're going to do that as part of the rest of the map section. So this bit works slightly differently. So we have a for loop. It's the same as it was before. It starts at 2. It goes up to x. And it is increased by 1 each time. This is a new bit. We say if random 1 to 100 is less than or equal to upchance, then we set z equal to 1 and z2 equal to 1. Otherwise, we set z equal to y and z2 equal to minus 1. Z is the y value of the first square we're going to fill in. And z2 is how much we're going to add to that initial value each time. So if random 1 to 100 is less than or equal to upchance, we're going to start at the bottom where y equals 1, and we're going to add 1 each time. If not, we're going to start at y, so start at the very top, and subtract 1 each time. So the way that we were doing it is each square, is influenced by the square to its west and the square to its south. The way that we're doing it now is if we're going up, it's the same as it was before. We use west and south. If we're going down, we use west and north, the squares to the immediate west and the immediate north. because if we tried to use the one to the south, we'd get a square we hadn't generated yet. So that wouldn't make any sense. So we had this initial line where we subtracted the difference between the square to the west and the square to the sorry, I was looking at the wrong line. Forget what I just said. Okay, so we set up the first square. And how do we set up the first square? We say map x to z, because z is where we're going to start. Map x to z equals random map x2 minus 1z minus 1 to map x2 minus 1z plus 1. So map x2 minus 1z is the square to the west. So we're saying the first square of the column that we're currently doing is going to be either 1 less than the square to its west, the same as the square to its west, or 1 more than the square to its west. And then that might have taken us out of the range that we want, because we want the range of values to be in between 1 and a particular number which we've stored in dollars range, $range. And so we deal with that by saying, if we've got a value of 0, make it a value of 1 or 2, because if it's a value of 0, that means the previous one had a value of 1 and we subtracted 1. But instead we want to, from 1, we never want to subtract from 1. We want to keep it the same or increase it. So make it either 1 or 2. And we have a similar thing at the sort of opposite end of the range. If it's greater than range, well, that must mean that the previous one was equal to range. It was the highest possible value and we added 1. And instead, we want to make it either range minus 1 or range. Then we do all the other squares in the column. And what I'm going to do is I'm going to write out how this loop used to be written, and then we can compare it to what we've got now more easily. So, and I'll sort of space it out so that the sections are under each other to make it easier. Oops. Okay. So what I've written there is what's underneath, what it was, and what's up here is what it currently is. So it used to be that we started at 2, we stopped when we got to y, and we add 1 each time. Well, that's what we're doing some of the time. That's starting from the bottom and going up, but we want to start from the top and go down sometimes. So we start y2 as being z plus z2, which means if we're going up, it'll start at 2, because 1 plus 1 is 2. And if we're going down, it'll be y, sorry, it's not, there we go. It'll be y plus minus 1, or y minus 1. Instead of stopping at y, we want to, instead of stopping at y, which is what we were doing last time, we want to stop at either y or 1. And so instead of saying y2 is less than or equal to y, being the stopping condition, or being the continuing condition, sorry, we say y2 is greater than 0 and y2 is less than or equal to y. If we wanted to use the same sign, we could have said y2 is greater than or equal to 1, just for consistency, but that greater than 0 and greater than or equal to 1 mean the same thing if you're dealing with only whole numbers. So it doesn't really matter, but I might change that in the version that I upload to itch.io. I might also put a note saying what Z2 and Z are, because I noticed I haven't done that. And so in other words, it's now saying keep going as long as you're between 1 and y inclusive. And we used to just add 1 to y. Now we either add 1 or subtract 1, so we say y2 equals y2 plus z2. So if we're going up, it'll be 1, and if we're going down, it'll be minus 1. The other changes we have to make are all to do with when we look at this. When we were looking at the square to the south, well, now we need to look at either the square to the south or the square to the north, depending on which way we're going. If we're going up, we look to the square to the north, and if we're going south, if we're going up, we look at the square to the south, and if we're going down, we look at the square to the north. So we just have to minus z2 from the current value of y. So if z2 is 1, we minus 1. If z2 is minus 1, we minus 1. In other words, we plot, which will be to plus 1. So an example of that, and I'll just delete that. So an example of that is here. We say map x2 minus 1 y2. That's the square to the west. This is what I thought. This line is what I thought this line was. I got a bit confused. So this is the height of the square immediately west minus the square immediately north or south, whereas in the first version it was the height of the square immediately west minus the square immediately south. So map x2 minus 1 y2 minus map x2 y2 minus z2. So that's the square to the north or the south. And then we keep the code the same as it was, except that whenever we had a reference to the square to the south, it's now the square to the north or south, which means x2 y2 minus z2 instead of x2 y2 minus 1. And once we've done every column, we display it exactly the same, because the change is in how we're getting those values, not what we're doing with the values once we've got them all. We display the map in the same way that we did before. Now, this is not a perfect solution in the sense that you'll get the slopes that it generates tend to be from sort of this sort of 45-degree angle to this kind of 45-degree angle. So it can be straight east to west. So it's everything within this sort of range, but it never does anything in this sort of range. It never does anything straight north to south or similar to straight north to south. So it's not like the real world where there really isn't a sort of orientation in a particular direction, but it is varied enough that a casual user probably wouldn't notice. So it is definitely better than it was. Now, it's easy enough to do. The problem is not getting a map that doesn't have a bias towards a particular angle. There are lots and lots of mechanisms for making maps. The problem is having a quick method of creating maps that doesn't do that. This isn't, there's probably at least half a dozen other ways of generating a map that look pretty realistic and don't have a bias towards sort of lines of the same height going in any particular direction. But those methods are a lot slower. I might show some of those if there's enough interest. But yeah, bear in mind the problem here is not how do we get rid of these lines. It's very easy to get rid of these lines. It's how do we get rid of these lines without making it take a lot longer. This algorithm, the value of it is its speed. It's a lot quicker than a lot of the methods that you'll see online, which is useful for Twine because Twine seems to be a little bit slow. Once you get into these really number-heavy type of algorithms, it can often slow the program right down and have gaps of time to process things that maybe aren't desirable. But anyway, we've made it a lot better. So I will leave it there. In the video to come, I will probably return to sort of my main project, which is coding the combat system for a viewer's game, and we're up to the situation where a monster appears sort of behind the party, and we have to deal with that. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.